Hello and welcome. In this video, we're going to learn about two-way tables and probability. Our goals are that we can create two-way tables, that we can find relative, joint, and conditional frequencies, and that we can use conditional relative frequencies to find and compare conditional probabilities. So let's go ahead and jump right in. Let's get started with some vocabulary. A two-way table is a frequency table that displays data from one source that belongs in two categories. So this right here is an example of a two-way table. A joint frequency represents the number of times a specific combination of two categories occurs. So for example, in this table, there are 40 children who like chocolate. So that is two different categories being combined to have one number. The marginal frequency refers to the sum of the frequencies for a particular category across all rows or columns. So in this particular table, we actually would have to add these two numbers to get the marginal number of people that chose chocolate, or the marginal number that were children if we added across. So I like the word marginal because it makes me think in the margins, or the combined total of the data for a specific row or column. So here's another visual of what we talked about with those vocabulary words before. We can see joint frequencies being these numbers in the middle here. We talked about marginal frequencies being in the margins, and you can see that here. But now we're going to add another component, and that component is really simply the word relative, which you can see showing up in each definition here. And really what that means is the number in that specific spot in relation or relative to the total number of that specific category. So we could say that there are 22 children that like to draw. That would be the joint frequency. If we wanted to make it a joint relative frequency, we would say that 22 out of the total, which is 100, 22 out of 100 responses were children that chose drawing. So it's joint in the sense that we're combining two categories together, but its relative frequency has to do with out of the total number, in this case, which was 100. Similarly, the marginal relative frequency, we're still looking at the margins, so we would say 49 out of 100 were children. In this case, 49 out of the 100 respondents were children. And then lastly, conditional relative frequency means that we are given a condition to start with. You can find a conditional relative frequency. We can use a condition to find a specific ratio. So given the condition that a respondent was a child, how many of them chose drawing? We could say 22 out of 49 children chose drawing. So you're given a specific condition, which is identifying a row or a column that you're going to be looking at, and then you're looking at the relative frequency within that. So I know this can seem like a lot of details here, but let's look at some examples and make sure we solidify the differences in each of these type of things and see how we can use those to find specific probabilities. So it's important to make sure that we could actually use given information to create a two-way table. So let's go ahead and read this together. This says, suppose you randomly survey juniors and seniors, so that's why we have juniors and seniors, about whether they are attending a school concert. 106 juniors and 114 seniors respond. So the total number of juniors is 106, the total number of seniors is 114, which actually means we can find the total number of people that responded simply by adding up and down. Of those, 42 juniors and 77 seniors plan on attending. So plan on attending would be, yes, 42 juniors and 77 seniors plan on attending. And again, we can add up and down to find those marginal numbers in the margins. We get 119. Part A is asking us to organize this data in a two-way table. So we could just use subtraction now to figure out what goes in each of these spots. So this would be 101, so that if I add these two numbers, I get 220. Go ahead and pause the video and fill in the rest of the table on your own. And now we have our completed table. So part B says, find and interpret the marginal frequencies. So I want you to grab, if you have a highlighter or anything. The marginal frequencies are the numbers that are in the margins. So really, and I'm going to come over here so I have more space. This is really just asking us to explain those margin numbers. So what does 106 mean? 106 was the number of juniors. So the survey included 106 juniors, which I know they told us that in the problem, but we're just interpreting the marginal numbers here. 114 seniors. This also had 119 students said yes to attend, and 101 said no. So basically, when we're being asked to find and interpret the marginal frequencies, we're being asked to explain what these numbers were. And we could even add up here, the survey included 220 students, comma, 106 juniors, 114 seniors, 119 said yes, 101 said no. So we're really just explaining what those margin numbers mean. Now we can take these numbers and we can turn them into ratios, 42 out of 220, 64 out of 220, in order to talk about the joint and marginal frequencies. So I'm going to copy that table over here so we can look at it. If we're being asked to find the joint and marginal relative frequencies, relative is that word that's telling me fraction. I know that 42 out of the 220 people that responded to this survey were juniors who said yes. If I plug that into a calculator, I can also get that ratio as a decimal. We know that 77 of the 220 people that responded to the survey were seniors who said yes, which is 0.35. 119 out of the 220 were the total number of people, so this would be marginal, who said yes out of the 220, which is 0.541. Go ahead and pause the video and fill in the remaining 6 spots on the table with both the fraction and the decimal version. Hopefully you gave yourself enough time to finish that off. You can go ahead and pause the video and make sure that our tables look the same before we jump into part D, where we're actually going to make a two-way table with this data that shows conditional relative frequency based on the row totals. So here we have part B, where we're going to be looking at the row totals. So we're going to take our total, our denominator for the junior row is going to be 0.482. So here we would say 0.191 divided by 0.482, or we would say 0.291 over 0.482. And then for our senior column, our denominator would be 0.518. And our numerators would be the two values we found here. So 0.35 and 0.168. And then go ahead and grab your calculator and plug these values in so that you get one decimal instead of 2 decimals in a fraction. Then unpause the video and see how you did. So hopefully you gave yourself enough time to do that and you can see these values. So the key difference, if we're looking at conditional, here we were being told that the conditions were the rows. So a condition was of the juniors, that's why our denominators were 0.482, or of the seniors, which is why our denominators were 0.518. So now we've been able to put our ability to create a two-way table to the test, and we've been able to use that vocabulary to create new tables that specifically focused on conditional, relative, marginal, all those different vocabulary terms. Let's put them together and look at a couple of more examples. All right, so for this example, we're going to focus on finding conditional probabilities. So let's look at this first example together. A satellite TV provider surveys customers in 3 different cities. So we can actually see in the two-way table what those 3 cities are: Glendale, Santa Monica, Long Beach. Then it says the survey asks whether they would recommend the TV provider to a friend. So whether, yes, they would recommend it, or no, they wouldn't recommend it. The results are given as joint relative frequencies shown in this two-way table below. So, for example, this number here, 0.29, represents the number of people surveyed who said Glendale and yes. 0.05 is the number of people who were surveyed that said Glendale and no. So we don't have the marginal information. We're probably going to have to add that marginal information along the sides to answer some of these conditional probability questions. But let's look at the questions before we figure out what we need to add. Question A says, what is the probability that a randomly selected customer who is located in Glendale, so of the people in Glendale, what is the probability that they will, yes, recommend the provider? So thinking back through the notation and the verbiage that we've learned, this question is really asking us, what is the probability that the answer is yes, given that we're looking at someone in Glendale? And this is how we would write that with the line, probability of yes, the line means given Glendale. So given Glendale means we're looking only at this column, and if we add these two values, that gives us the sum of what percentage of people were in Glendale. So given, that's going to be in the denominator, given that we're in the Glendale column, that's our denominator, 0.34. Given that information, what number of those people chose yes? So given 0.34, what's the yes in that column? The yes is 0.29. And then you can grab a calculator and do 0.29 divided by 0.34, and this is going to give you 0.853. So the probability that someone would recommend the provider, given that they are from Glendale, is 0.853. All right, so part B says, what is the probability that a randomly selected customer who will not recommend the provider, meaning of the people that did not recommend the provider, what is the probability that that person is randomly selected is from Long Beach? So I'm going to encourage you to pause the video, work through part B on your own, and then unpause the video and see how you did. Hopefully you had time to work through that. This question is asking us for the probability of Long Beach given no. So we're looking at the no column. If we sum the values across this column, we're going to get 0.12 is the sum, is how many people chose no. So given that no was the response, the probability of someone being from Long Beach is going to be that number in the Long Beach column. And if we simplify this fraction, we end up getting 1/3 or 0.33 repeating. Okay, part C, we're going to tie back to the idea of dependent and independent, which we talked about in 1.2. Part C says, determine whether recommending the provider to a friend and living in Long Beach are independent events. So to bring us back to the last section, what that really means is we need to figure out what the probability of someone being from Long Beach is, and we need to figure out the probability of Long Beach given that the response was yes. And if these two things are the same, then they're independent events. And if they're not the same, then they're dependent. So go ahead and pause the video and use the table to find those probabilities, and then compare and answer the question. Then unpause the video and see how you did. Okay, so let's talk through this together. The probability of Long Beach is just the sum of the number of people that were surveyed from Long Beach, which is 0.36. The probability of Long Beach, given that the answer is yes, is the total number of yeses, or the sum of the yes row, which is 0.88. And then the number of responses that are Long Beach and yes, which is 0.32. So 0.32 over 0.88, which is 0.36. And these two values are in fact the same, which means that living in Long Beach and recommending the provider to a friend are in fact independent events. So go ahead and write a sentence that answers the question being asked here. And there you have it. Let's look at another example. All right, number 3 says a jogger wants to burn a certain number of calories during his workout. He maps out 3 possible jogging routes. Before each workout, he randomly selects a route and then determines the number of calories he burns and whether he reaches his goal. The table shows his findings, so you see the table on the right. For part A, you're going to make a two-way table that shows the joint and marginal relative frequencies. So your values should be decimals. You shouldn't have like 50 in there or 10 in there. You should have whatever the fraction over the total is. So for part A, you're going to fill in the two-way table. And then for part B, you're going to find the conditional probabilities by dividing each joint relative frequency in the yes column by the marginal frequency in its corresponding row. And then you're going to draw a conclusion and write a sentence explaining which route should be used. So what I'm going to do is I'm going to encourage you to pause the video and see how far you can get on here, and then unpause the video and follow through the problem with me. So hopefully you've at least made your three-way table, and you can see mine here, and I tried to color code. There are 50 total observations, so that's going to be my denominator for each of these. And then I came over here and I used pink to figure out how many in route A they reached the goal 11 times in B, 12 times in C, and then I summed them for the total. Same thing for did not reach the goal, 6, 4, 6, added those to get 16, and just found those values as decimals. So now you're going to find the probability of yes given A, the probability of yes given B, and the probability of yes given C, and then you're going to determine which route this jogger should use, assuming that he wants to reach his goal as many times as possible. So if you haven't already found those probabilities, pause the video and find those probabilities. So here we go, and again, trying to color code for you. We can see the probability of yes given A is 0.647. So given that we're out of the 0.34, the probability that they said yes in that row is 0.22. Similarly, for B, 0.22 over 0.3, and then for C, 0.24 over 0.36. So of these three probabilities, the highest one is probability of yes given B. So now we need to write a sentence that explains that we believe that based on this data, actually not just we believe, based on this data, the jogger should take route B to increase the likelihood of him meeting his goal. So we need to just write a sentence summarizing our results here. And there we have it. Let's look at one last example and then wrap this up. All right, our last example, a manager is assessing 3 employees in order to offer one of them a promotion. Over a period of time, the manager records whether the employee meets or exceeds expectations on their assigned task. The table shows the manager's results. Which employee should be offered the promotion? Explain. So it doesn't tell you that you have to make a two-way table. It doesn't tell you that you have to check the conditional probability, but this entire section is about not just looking at the data and saying what we think. Oh, based on this, I think it should be Alina because she exceeded expectations the most. What you need to do is you need to look at those conditional probabilities. So I would recommend, whether you add to this table or you make a separate table, that you actually look at those conditional probabilities, the percentages as decimals, the same way that we looked at 3, A and B, and you come up with a sentence that you can back up with the data. Just being able to explain, based on this data, this person had it the most times, that's really not going to be enough. So you need to be able to support your claim with evidence. So pause the video, see how far you can get on your own, and then unpause the video and walk through it with me. Okay, so this is a lot of work to answer this question, but the whole point here is we're backing up what we're claiming. So here I made a two-way table where I looked at the joint frequencies. That way we could look at the probability of someone exceeding, given that that someone is Joy, versus Alina versus Sam. If I compare all of those conditional probabilities, I want to hire I want to promote the employee that has the highest exceed rate, and that is Sam. So Sam should be offered the promotion since the probability of Sam exceeding the expectations is the highest. So we're going to wrap up this problem by writing that out as a sentence to answer the question. And our explanation or our justification is coming from the work above. There we go. Let's go ahead and wrap this up. All right, in this video, our goal was to be able to create two-way tables, to be able to find relative, joint, and conditional frequencies, and that we could use conditional relative frequencies to find and compare conditional probabilities. So hopefully you have a better understanding of all these different types of two-way tables and how to use that data to draw conclusions. Go ahead and write down any questions you have, and I look forward to supporting you with this. Thanks for listening.